Hello, I wanted to show you how to integrate this question because I think it's a very curious thing that you may need in other questions. You have a trigonometric function and an exponential function, which means we could easily use integration by parts, and we know how to integrate both and how to differentiate both. None of them gets simpler than the other when we differentiate, so it really doesn't matter which one we choose as u, as dv. So remember, when I integrate by parts, I have the integral of u dv is u v minus v du. So if I call u to e to the power of x, for example, and dv to cos x dx, I'm going to differentiate this one and to integrate this one. To find du, so du is going to be e to the power of x dx. And when I integrate dv to have v, the integral of cos is sine x. And I'm going to substitute this into my integral. So here I have, I'm going to use the formula. It's not that I'm going to substitute in the integral, I'm going to use the formula. So uv is e to the power of x sine x. E to the power of x sine x. Minus the integral of v du. V is sine x, du is ex dx. So I have something very similar to what I had before. Yeah, but instead of cos, I have sine. So what I can do is apply integration by parts again here. So if I just separate this, I'm going to integrate that. So I have integral of e to the power of x sine x, and I'm doing the same. So I can call u to e to the power of x to be consistent, dv to sine x dx. So I differentiate this one, so du is e to the power of x dx, and I integrate this one to have v, so integral of sine x dx, which is minus cos x. And I substitute in the formula. So if I go back here, I have uv, so using this into the formula, I have uv, so uv is minus e to the power of x cos x, and minus integral of v du. V is cos x, minus, and I have a plus here because I have the minus from the formula and the minus here, it becomes plus e to the power of x cos x dx. Yeah. So, and this is, if you notice, the same that we have at the beginning. So what is happening is this integral here, using parts, is this bit here. And this is going to be this one. So if I write the whole thing, I have integral of e to the power of x cos x dx is going to be equal to e to the power of x sine x minus this integral is all this thing here. So I'm going to write minus, is this minus, brackets, I have minus e to the power of x cos x plus integral of e to the power of x cos x dx. Yeah? I'm going to expand the bracket just for the signs, and I have e to the power of x cos x dx is e to the power of x sine x, minus minus is plus, e to the power of x cos x minus integral of e to the power of x cos x dx. If you notice, I have that this integral and this integral are the same and are the one that we are looking, we are trying to find out. So what we are going to do is to rearrange this equation that I have here. So this one together with this one, I have two integrals of e to the power of x cos x dx is going to be equal to e to the power of x sine x plus e to the power of x cos x, which means the integral that I'm looking for is the expression I have on the right divided by 2. Yeah, so e to the power of x sine x plus e to the power of x cos x divided by 2. Yeah, or if you prefer, you can write as e to the power of x divided by 2 multiply sine x cos x. Is another way of writing it, but that's the same idea. Yeah. And the constant of integration, sorry, I'm forgetting it. So I can add it here, or if you prefer the expression like it is in the second one, like here. Yeah. So don't forget the constant of integration because it could be 1 mark. So in summary, you have this integral, you use parts, you get a nice expression and another integral very similar to the initial one. You use parts again to solve it. And that way you're going to have that your integral is equal to this nice expression minus this whole thing. I put a bracket so I don't get mistakes with the signs. I expand the brackets and I find that I have this integral and this integral are the same. So I regroup them, put them together in one side of the equation equal to this, and then I divide by 2. Yep, and that's all with this question.